Okay, guys. Lesson 3.3. Again, we're moving through this chapter pretty quick. When we come back from Thanksgiving, we'll be finishing 3.4, 3.5, 3.6 in those first 3 days back. So, chapter 3 goes very quickly. This is probably the only lesson I'll end up spending 2 days on. And it's just because really 3.2 ran a little over yesterday. So, lesson 3, logarithms. You had these in Algebra 2 some. Yes? Well, there'll be a test. Yes. We will have a chapter 3 test. Probably, if they go exactly, it would be that next Monday then. So I'll wait and see how that week goes and go from there. No. No, it's such a quick chapter that I just go with a test at the end. Okay, guys. We are looking logarithms, logarithmic functions and graphs. We did this some in Algebra 2. I'm trying to think, did we do it before Algebra 2? Probably not. I don't know. Okay, so logarithms. First of all, right there, guys, log base b of x equals y. Basic log form there. Okay, so log base b of x equals y. One of the big things you have to know about logarithms, wherever they pop up, okay, whether I'm actually teaching about them, whether they pop up in another lesson or section, you have to know how to go from a logarithm form to the exponential form. And that is the big thing, okay? So if it's log base b of x equals y, then exponential form, that becomes b to the y equals x. And the phrase left, right, middle, does that jog some memories? Okay? So if you see me write LRM on something, that's me indicating left, right, middle. Know that phrase. We're going to use it a lot. So left, right, middle is how you can go out of logarithm notation into exponential notation. Now, the word log has to be on the left, and the idea is it becomes the base b, so the left, raised to the right y equals the middle x. So left, right, middle. Or figure out a different way to remember it. Okay? It's just a necessary part of math. So, we're going to do several different things here. Example 1 asks us to evaluate the following. So, what is log base 2 of 8? Now, if you remember, what's the basic log button on your calculator? It's log base 10, isn't it? Okay? So, this does not work, just hitting a log button. My recommendation on this is let's make this equal to a variable. I'm going to use y. You can use x if you want. So what do you know about log base 2 of 8 equals y? What's left, right, middle say? Okay, I can rewrite this as 2 to the y equals 8. How do I solve when y is in the exponent? What do we try and do with that 2 and 8? Okay, y does equal 3. Why does y equal 3? Okay, because 2 to the third equals 8. So do you guys remember this? We want to try and take that 2 and 8 and make them the same base. So if I rewrite this, 2 to the y, what do you know about 8? 8 is 2 to the third. If the bases are the same, then the exponents are the same. So the 2's are the same, drop the 2's, and y equals 3. So that means log base 2 of 8 equals 3. Okay, try B. Log base 3 of square root of 3, and you don't necessarily have to write it, but I'm going to write equals y. How can I change this? Okay, 3 to the y equals square root of 3. What do you know? Can I make those bases the same? Yeah, the square root of 3. How do I write that with a base? That is 3 to the 1/2 power. We talked about that recently, didn't we? Okay, where the denominator of 2, that denominator of 2 is the square root, the power of 1 is the numerator there. So if 3 to the y equals 3 to the 1/2, then what's y? 1/2. So log base 3 of square root of 3 is equal to 1/2. Okay, so that was your reminder that square roots or any type of radicals involve fraction exponents. Okay, C, log base 5 of 1/25. Again, I'm going to put it equals to y. What's the expression I write? Left, right, middle. 5 to the y equals 1/25. What do you know? How can I make these bases the same? A negative. Okay. So one thing you know that 25 is what? 5 squared, right? So if I think about that as 1 over 5 squared, how do you get 5 squared out of the denominator? You make it a negative exponent. So 5 to the y equals 5 to the negative second. So negatives take it out of the denominator. So log base 5 of 1/25 equals -2. Okay, D. Log base 4 of 1. Okay. If I make this equal to y, 4 to the y equals 1. What do you guys know here? How do you get something to equal 1 when we're talking exponents? 0 power, yes? So I could rewrite this as 4 to the y equals 4 to the 0. Because is 4 to the 0 still 1? Yeah, anything raised to 0 is 1. And so that means y equals 0. And we'll talk about some properties that will make some of these easier so you don't actually have to work them out. Log base 7 of 7. So if you say equals y, 7 to the y equals 7. What's the invisible power there? 1. So 7 to the y equals 7 to the first. And so y equals 1. Okay, left, right, middle. Sounds familiar, right? I will be honest, we took the long way on some of these problems we just did. Kind of kills me in a way to lead you guys through that way, but my point leading you guys through that way is any logarithm you can set up left, right, middle. Okay, so if all else fails, left, right, middle is there. In this next section, we have some properties of logs. And these are really good properties to know. Log base b of 1 equals 0. That's saying it doesn't matter what the base is. If it's log of 1, it's always going to equal 0. What happened in example D? Log base 4 of 1 equaled 0. So my point is, if you see log of 1, just make it equal 0. Don't go through all the work. Example 2, or property 2. Log base b of b equals 1. That's saying if the base of the log and the inside of the logs are the same, those b's match, it equals 1. Thus, that was example E. Log base 7 of 7 equaled 1. Okay, 3. Log base b of b to the y equals y. So that's saying if your base your bases are the same. So base of the log and base of the insides are the same. That log expression is equal to whatever the exponent is. And really that kind of happened on A, B, and C. Because I could have taken A and written it as log base 2 of 2 to the third. And that's what would happen. And then lastly, number 4, this is the one we haven't dealt with yet. If you have a base B raised to a power log base B of y, as long as those b's are the same, so the base B and the base of the log, it's going to equal the insides of the log. So when I say the insides of the log, I'm talking about like the main number in the log. Not the base of the log, but the number inside the log. Okay? Again, you can go through problems and not know those properties, but it will speed things up if you know those properties. Some of your homework is just answering questions like E, log base 7 of 7. You should be able to say it's 1 because my 7's match. That's what some of your 40 problems of homework are there. Now, example 2. The directions in this section specifically say use the laws, or in other words, properties of logarithms to evaluate. Meaning, I don't want to do a left, right, middle. Not saying we couldn't do a left, right, middle, but I want to use my laws and properties instead. So, log base 3 of 27. So instead of doing left, right, middle, what do you guys know about 27? It's 3 to the third. And I guess I can, if you want me to go farther, what do you guys know about 27 in relation to 3? And 27 is 3 to the third. So if I rewrite this, for you guys to see it better, log base 3 of 27 is 3 to the third. What does log base 3 of 27 equal then? Equals 3. Now, let me be nitpicky. Which 3? This is kind of a bad example for the first example. Okay, this 3 up here, yes? It's because these first 2 3's match, then this answer is the exponent 3. So if you can make them match, that's what you want to do. Log base 2 of square root of 2. What do you guys know about the square root of 2? It's 2 to the what? 1/2. So if it's log base 2 of 2 to the 1/2, what does this log expression equal? 1/2. Again, 1/2 because that was the property. C, log base 25 of 25. 1? Because the 25's match, right? No work to show there. Just write your answer. D, 6 raised to log base 6 of 7. Because those 6's match, my answer is 7. Log base 8 of 1. 0 because it is a log of 1. Okay. The more you know these rules, guys, the easier life will be. And again, left, right, middle. You just got to know that when you see logs. That will randomly pop up throughout math. Okay, common logs. When we talk about common logs are when it's log base 10, which again, we already mentioned, log base 10 is what your calculator, the basic, when you find the log button on a calculator, that's log base 10. So common logs are log base 10 of x, and notice, a way to write log base 10 of x, because it's the common log, is to just write log of x. Do you have to write that 10? Now, if I see a log without a base on it, I assume it's 10. If it's something other than 10, you have to write it. If it's 10, you don't, have to write it. So, notice what this question says. Evaluate each of the following without a calculator. And we're saying that because technically, could you just plug them into a calculator? Yeah, but these are easy ones to do without a calculator. What do you guys notice about log of 100? 100 is 10 squared. And is that helpful? Yeah. Because it's already log base what? It's log base 10 of 10 squared. Yes, I wrote the base 10 in there just to make the point of the matching 10s. And so this is equal to 2. Did you need a calculator for that? No. Could you check yourself on the calculator? Sure. You enter log 100 in your calculator, you're going to get 2 back out at you. B. Log of the, what's that say, 5th root of 10? What do you know about the 5th root of 10? It's log of 10 to the 1/5. And again, since that invisible base 10 is there, this equals 1/5. C. Log of 1/1000. What do you know about 1,000? 1,000 is a 1 with 3 zeros, so that makes it what? 10 to the 3rd. So 1/1000th is 1 over 10 to the 3rd. How do we get that out of the denominator? Negative exponent, right? So it's log of 10 to the negative 3rd. My 10s match, so this is negative 3. D. 10 raised to the power of log 6. What's it equal to? 6. Because why? There's an invisible 10 base, right? So those 10s match, and so this is equal to 6. Log of 1. Where is my class? Really, guys? Log of 1. 0. That's one we all know, right? Or here's my, I guess if you don't know it, stick it in your memory. Okay? Okay, so that was using it without a calculator. Know those rules, guys. Example 4. What's example 4 say? Evaluate the following using your calculator. So grab your calculator. Make sure, nothing else, you know where your log button is and how to use it. Okay. Log of 34.5. You guys got it? Type in log, hit the log button, type in 34.5. Got the right answer? Okay, I have mine to 3 decimal places. So if we go 3 decimal places, that is approximately 1.538. Okay. So notice that's log of 34.5. We get a positive result. Log of 4300ths. Negative point what?
367.
Yeah, how about 367? So if we do log of 0.43, negative 0.366, but the 5 tells the 6 to go up. So if I'm going 3 decimal places, it's approximately negative 0.367. Guys, that one was negative because I had a number less than 1. When you do a log of a number between 0 and 1, you're going to have a negative. If you have a log of a number bigger than 1, you're going to have a positive. Log of negative 3. Okay, so if I hit log of negative 3, it says error. Learn to read your errors, guys, because I know a lot of you guys just see error and you just clear off of it and you don't know what to think there. Notice it says non-real answers. Okay? In real mode, all calculations must result in a real number. What are we essentially saying? Can you do the log of a negative number? No. Okay? There might be an imaginary solution. Honestly, I've never dealt with that, so I have no idea. But that's what they're indicating. And so, this is not possible. I'm going to write undefined. Is what I'm going to write. I get it. No solution gives the same idea. And I want to show you real quick why this is undefined. Do you guys remember what our log graph looks like from lesson 1-2 and or lesson 1-3 in our 12 graphs? The log graph is the inverse of the exponential graph. We just did exponential graphs the other day, right? And the exponential graph runs along the x-axis, cuts up through the y, and goes up to infinity, right? So this is the inverse of it. So this is technically reflected over that y equals x line. So this runs down along the y-axis, cuts through the x-axis, and looks like that. Why can I not do a log of a negative number? Does my graph exist over here? Where x would be negative, my graph doesn't exist. And that's, as you try and remember this rule, that you cannot take the log of a negative number. Here's your reminder, okay? My domains, the only thing I can use in logs are positive numbers. So I'll write it right here again as a reminder. The domain is positive real numbers. Helpful to know, okay? When it comes to anytime you have to check something, if it's taking log of a negative number, realize it's not going to be an option. You can't take a log of a negative number. Okay, questions there? It's probably our best stopping point, isn't it? We'll pick up on example 5 on Monday, where we will be solving some equations. And then on the back side, we will talk about natural logs. So we talked about common logs today. We'll talk about natural logs on Monday. Homework will not be due till Tuesday. However, if you're concerned about an abundance of 40 problems, you're welcome to get started.